When a circuit breaker is rated at 20 amps, the corresponding receptacle should also be rated for 20 amps. This ensures the receptacle can safely handle the potential current the circuit breaker allows. In the kitchen, if the circuit breakers are 20 amps, then the receptacle should also be 20 amp rated. This is because a 20 amp circuit is designed to handle a higher load than a 15 amp circuit. Using a 15 amp receptacle on a 20 amp circuit creates a potential safety hazard, as the receptacle may overheat if the circuit is fully loaded. Regarding ground fault circuit interrupter protection in bathrooms, it is permissible to have a single 20 amp GFCI receptacle protecting multiple outlets. However, it is not the ideal configuration. If the single GFCI trips, it will cut power to all the connected outlets, which can be inconvenient. A better practice is to install individual GFCI outlets for each receptacle. This way, if one GFCI trips, it only affects the corresponding outlet, minimizing disruption. Having both bathrooms on a single 15 amp circuit is not recommended. Bathrooms often contain high power appliances such as hair dryers and electric razors. Running these appliances simultaneously on a shared 15 amp circuit can easily overload the circuit, causing the circuit breaker to trip or potentially creating a fire hazard. It is much safer to separate the bathrooms onto two dedicated 15 amp circuits. This reduces the risk of overloading and provides a more reliable power supply for each bathroom. Here are some general recommendations for electrical safety. Firstly, it is highly recommended to have a qualified, licensed electrician inspect the electrical system in your home. An electrician can identify potential hazards, ensure the wiring is up to code, and make recommendations for improvements. Secondly, upgrade the receptacles to match the amperage of the circuits they are on. Replace any 15 amp receptacles on 20 amp circuits with 20 amp receptacles. This ensures the receptacles can safely handle the potential current. Thirdly, install dedicated GFCI outlets for each bathroom receptacle. This provides enhanced safety and minimizes inconvenience if a GFCI trips. Fourthly, consider separating the bathroom circuits. Running each bathroom on its own 15 amp circuit reduces the risk of overloading and ensures a more reliable power supply. For further clarification, let's delve deeper into the reasons behind these recommendations. Using the correct receptacle amperage is paramount for safety. A 15 amp receptacle is designed to handle a maximum current of 15 amps. If it is connected to a 20 amp circuit, it could be subjected to a higher current than it is rated for. This can lead to overheating, melting, and potentially a fire. 20 amp receptacles have a different configuration than 15 amp receptacles. 20 amp receptacles have one slot that looks like a T-shape. This T-shape is so a 20 amp plug can only fit into a 20 amp receptacle. GFCI protection is essential in bathrooms due to the presence of water. GFCIs are designed to detect ground faults, which occur when electricity flows through an unintended path, such as through a person touching a live wire while in contact with water. GFCIs quickly interrupt the circuit, preventing electrical shock. The National Electrical Code requires GFCI protection for all receptacles in bathrooms. While a single GFCI can protect multiple outlets, individual GFCIs provide a higher level of safety and convenience. Sharing a single 15 amp circuit between two bathrooms is problematic because it increases the likelihood of overloading. Consider a scenario where someone is using a 1200 watt hairdryer in one bathroom and another person is using an 800 watt electric razor in the other bathroom. That would be 2000 watts, and at 120 volts, that's 16.66 amps. This exceeds the 15 amp capacity of the circuit, causing the circuit breaker to trip. Separating the bathrooms onto two circuits reduces the chances of this happening. In a typical residential electrical system, the service entrance provides power to the entire house. This power is then distributed to various circuits through the electrical panel, which houses the circuit breakers. Circuit breakers are designed to protect the wiring from overcurrents. When the current in a circuit exceeds the breaker's rating, the breaker trips, interrupting the flow of electricity. This prevents the wiring from overheating and potentially causing a fire. The National Electrical Code, or NEC, sets the standards for safe electrical installations. It provides guidelines for wire sizing, circuit breaker ratings, receptacle types, and GFCI protection. It is important to adhere to the NEC guidelines to ensure the electrical system is safe and compliant. When an electrician inspects the electrical system, they will check for compliance with the NEC. They will also look for any signs of damage or deterioration, such as frayed wiring, loose connections, or corroded components. Upgrading receptacles to the correct amperage is a straightforward process. The first step is to turn off the circuit breaker that controls the receptacle. Then remove the existing receptacle from the electrical box. Identify the wires connected to the receptacle. Typically, there will be a black wire, which is the hot wire, a white wire, which is the neutral wire, and a green or bare copper wire, which is the ground wire. Disconnect the wires from the old receptacle and connect them to the new receptacle, making sure to match the wire colors to the corresponding terminals. Secure the new receptacle in the electrical box and replace the cover plate. Finally, turn the circuit breaker back on and test the receptacle to ensure it is working properly. Installing dedicated GFCI outlets is similar to upgrading standard receptacles. The main difference is that GFCI outlets have additional wiring requirements. GFCI outlets have line terminals, which connect to the incoming power, and load terminals, which connect to the downstream wiring. When installing a GFCI outlet, it is important to connect the wires to the correct terminals. The line terminal should be connected to the wires coming from the circuit breaker, and the load terminal should be connected to the wires going to the other outlets on the circuit. If the wiring is not done correctly, the GFCI will not function properly. Separating bathroom circuits involves running new wiring from the electrical panel to the bathrooms. This is a more complex task that should be performed by a qualified electrician. The electrician will need to determine the appropriate wire size for the new circuits and install new circuit breakers in the electrical panel. They will also need to run the wiring through the walls and ceilings to the bathrooms, making sure to comply with the NEC guidelines. In addition to the recommendations above, there are a few other things to consider when evaluating the electrical system. Check for any signs of overloaded circuits, such as flickering lights, warm outlets, or frequently tripping circuit breakers. If you notice any of these signs, it is important to investigate the cause and take corrective action. Avoid using extension cords as a permanent solution. Extension cords are intended for temporary use only. If you need additional outlets, have a qualified electrician install them. Protect electrical cords from damage. Avoid running cords under rugs or furniture, where they can be easily damaged. Replace any damaged cords immediately. Keep electrical appliances away from water. Never use electrical appliances near sinks, bathtubs, or showers. If an electrical appliance falls into water, do not touch it. Turn off the circuit breaker that controls the appliance and then retrieve it. By following these recommendations, you can ensure the electrical system is safe and reliable. Remember, when in doubt, always consult a qualified electrician. Electricity is a powerful force, and it is important to take precautions to avoid electrical shock and fire hazards. To further illustrate the importance of proper electrical practices, consider the potential consequences of ignoring these guidelines. An overloaded circuit can cause the wiring to overheat, which can lead to a fire. A faulty GFCI can fail to protect you from electrical shock. A damaged electrical cord can expose live wires, creating a serious hazard. By taking the time to inspect the electrical system and make necessary repairs, you can protect yourself and your family from these dangers. Understanding basic electrical concepts can empower you to make informed decisions about your home's electrical system. Voltage is the electrical pressure that pushes electricity through a circuit. Amperage is the amount of electrical current flowing through a circuit. Wattage is the amount of electrical power consumed by an appliance. These three quantities are related by the formula watt equals volts times amps. For example, a 1200 watt hairdryer plugged into a 120 volt outlet draws 10 amps of current. Wire size is another important factor to consider. The size of the wire determines how much current it can safely carry. The NEC specifies the appropriate wire size for different circuit breaker ratings. Using undersized wiring can cause the wire to overheat and potentially cause a fire. Common wire sizes used in residential wiring include 14-gauge wire, which is typically used for 15-amp circuits, and 12-gauge wire, which is typically used for 20-amp circuits. When working with electricity, it is important to use the right tools. Use insulated tools designed for electrical work. Wear rubber gloves and safety glasses to protect yourself from electrical shock and arc flash. Always turn off the circuit breaker before working on any electrical wiring. Double check that the circuit is de-energized before touching any wires. Use a voltage tester to verify that the circuit is dead. Electrical safety is not just a matter of following the rules. It is also a matter of using common sense. If something doesn't seem right, don't take chances. Call a qualified electrician to investigate the problem. Your safety and the safety of your family are worth it. Remember to always prioritize safety when working with electricity. A little knowledge and caution can go a long way in preventing accidents and ensuring a safe home. These tips and advice should help make the home safer.